Well, today we are going to see about three-dimensional transformation in computer graphics. As we have seen in previous classes, what do you know about transformation? And we have already seen what do you call as a two-dimensional transformation in the previous chapter itself. The same one, we are going to see all the different transformation categories. That is translation, rotation, scaling, shearing, reflection. All this we are discussed in previous chapter itself in the topic of two-dimensional transformation. So what you call as 2D and 3D, that difference also we know very well. So 2D is nothing but two-dimension. It will includes only two planes, X and Y planes. Whereas in 3D, we are going to add one extra axis called z-axis that we consider as what? Three-dimensional transformation. So the types are same only. See here, there are different type of 3D transformation. These types are similar to the two-dimensional transformation. So transformation, we know that it is nothing but in order to change any size, or you want to move an object from one position to another, or you want to create any orientations to that particular objects. So for that, we need the transformation concept. So these are the different types available in 3D transformation also. And what is the next topic we are going to see in today's class is that viewing transformation. So let me see one by one. First, 3D. 3D means what? Three-dimensional transformation. In the 2D system, we use only two coordinates, X and Y coordinates. But in 3D, we are going to add on extra coordinate. Z-axis is added. See this diagram, X and Y axis, we already seen in 2D dimension itself. Here we are adding on a x-axis, extra axis called z-axis. This is what 3D deals with. So first type, 3D translation. That is three-dimensional translation. It is nothing but if you want to move an object from one position to another, that we call as what? 3D translation. So in 3D translation, in three-dimensional homogeneous coordinate representation, if you are going to represent in a homogeneous coordinate, a point is transformed from position p equal to x comma y comma z to p dash equal to x dash comma y dash comma z dash. Here you see this diagram, x-axis, y-axis and z-axis are given. So the original point is x, y and z. There is nothing but original position. You are going to move an object from this, translate an object from this position to new position using the translation distances t equal to tx comma ty comma tz. So with the help of this translation distance only, we are going to move an object from one position to another. So the new position we call it as what? P dash equal to x dash comma y dash comma z dash. So this can be written as in homogeneous coordinate transformation using this formula p dash equal to t into p. As we know that three-dimensional transformation deals with 3 by 3 matrix. The same representation is given here. X-axis, y-axis, z-axis, 1. This p dash values or expressions are x dash, y dash, and z dash. So this one we called as in what? Homogeneous coordinate representation. We are adding only extra coordinates to the transformation. So for 1, I'm giving here, that is 1 0 0 0 1 0 0 double 0 1. It is nothing but x, y, and z. The last one is default only 0 0 1. So see this. What is our t value here? That is translation distance is tx comma ty tez. Then last one is 1. The default value last one is 1. So into what you are going to calculate? Into p, that is original position x, y, z, and 1. So this is what the expression of the 3D translation. So next we are going to see about 3D rotation. So in 3D rotation, we have to specify the angle of rotation along with the axis of rotation. That is the axis of rotation. Here we are mentioning that we can perform three-dimensional rotation about x-axis, y-axis, and z-axis. So see this below diagram. You can clearly understand that rotation about x-axis means it is going to rotate in the x direction. Rotation about y-axis means you are going to rotate in y-axis direction. Then rotation about z-axis is you are going to rotate in the z-axis direction. This is what the 3D rotation consider. So the angle of rotation will be going for all the three axes. Whereas in 2D, we have seen only the xn, that is horizontal to the vertical. That is what we have seen in the two-dimensional transformation. But here in three-dimensional rotation, we can perform all the that is rotation in all the axis, x-axis, y-axis, and z-axis. So next topic, we are going to see the remaining scaling, reflection, shearing, that are all common compared to 2D transformation and 3D transformation. So that's why I skip that topic and coming to the new topic called viewing transformation. So what do you call as a viewing transformation? The mapping of world coordinates to viewport coordinates is called viewing transformation. World coordinates is nothing but, let me consider one example. If you are seeing any image, that image may be seen only at a particular display area, that we consider what means world coordinates. So from that particular display area, if you are selecting any display area, from the display area, you are going to select the only the particular region that we consider as what viewport. So see this diagram, you can clearly understand what we call as world coordinates and view device coordinates. So see this diagram here. I'm giving that this image, that is whatever we are seeing, this is our display scene. Okay. So in this we are seeing this image, whereas I'm using the window, that is I'm going to select one region. Okay, not the particular region, I'm going to select the visible region. What I am going to see, that is what I'm going to clip through the help of the window concept. That is what window deals with. Whereas viewport, what you going to do in viewport means, I'm going to select only that particular region for display, that we can say what viewport. So the window is nothing but whole entire display. From that you are going to clip that particular region. That clipping, after clipping, what the image you are getting is viewport. So that is what given here. The mapping of world coordinates to viewport coordinates is called viewing transformation. It includes two concepts, window and then viewport. Here you are for measuring, we are given that XW mean, that is XW is nothing but XW is nothing but window minimum. XW maximum is X window maximum. Here we are giving that XV minimum, XV maximum is nothing but X view minimum, X view maximum. Like that, similar to the YV minimum and YV max, and YW minimum and YW max. So next, in additional to that viewing transformation, we have a beautiful concept called projection. Whereas in 2D, we not include this topic. In 3D only, that is three-dimensional transformation only, we are going to see this projection concept. So what you call as a projection is nothing but, it is defined as a mapping of three-dimensional points to two-dimensional plane. That is what projection. There are two types of projection in that. One is parallel and perspective. So later we see with the types of projection in the remaining slides. So first you say, what do you call as a projection is nothing but standard projections will project onto a plane, that we can say what projections. Projections are lines that either coverage at a center of projection or it is parallel. These are the terms and conditions for the projections. Then such projections preserve lines but not necessary angles. Whereas you are going for the non-parallel projection that are needed for applications such as map construction, that is also deals with the projection. So these are the different classification projection diagrams. First you see this front elevation. From the front elevation, I consider on building. In that building, if you are seeing the building in a front means, you will get this display scene like this. Whereas if you are going with the elevation oblique projection, you will see this building like this. That is, display will be like this one. Whereas planned oblique like this, and isometric, the display will be like this. And 1 point perspective and 3 point perspective, the projection will be like this only. 1 point perspective you are going to see only in the div, and 3 point perspective you are having 3 different views. That is what given here. So these are the different types of projections available in three-dimensional transformation. So projection is mainly classified into two categories, parallel and then perspective, that we know. So what you call as a parallel projection is nothing but it is used by architects and engineers for creating working drawing of the object. For complete representations, we require two or more views of an object using different planes. So we already seen in the previous diagram itself. So what this parallel projection will be used, what is the purpose for that, that and all we see the individual diagrams of the parallel and perspective projection. First you see this, these are the different categories of parallel and perspective. Parallel includes multi-view, orthographic, axonometric, oblique. The axonometric is again classified into isometric, diametric and trimetric. Whereas perspective views, we are having 1 point, 2 point and 3 point. So first you see this perspective projection. So what you call as perspective projection is nothing but that parallel projection is used by architect, means this is used by artist also for drawing three-dimensional scenes. So in perspective projections, the lines of the projection do not remain parallel. See this diagram, this is not remain to be parallel. The lines coverage at a single point, see the center of the projection. The image of this on the screen. So this is the image, means object. This is we consider an image. This object we consider an image. The image on the screen, okay, image on the screen is obtained by points of intersection, that is center of points of intersection on converging lines with the plane on the screen. Okay, this conversion lines is nothing but plane. Which one we consider plane? This one, projection plane. Okay. So what this image on the image on the screen is seen as, means as of viewer's eye were located at the center of the projection, and the lines of the projection would correspond to path traveled by light beam. Okay, this one we consider light beam. Whenever we are getting the light beam reflection, it is originating from the object. So this is the characteristics of perspective projection. Apart from this, there are two main characteristics of perspective projection. It is varnishing points and the perspective forecasting. These are the two different characteristics of perspective projections. So in this diagram itself, we clearly mentioned that object we are going to project on a projection plane, and you are going to see by the center of the projection. You are going to locate the object at the, we are going to locate at the view of the object in the center of the projection. The next one is parallel projection. Parallel projection is same, so it is used to display the picture. Okay, so this is our picture, means this is used to display the picture in its true shape and size. Okay, so this is our shape, that shape only display in the projection plane. When projectors, okay, when projectors are perpendicular, okay, it is perpendicular to the view plane, this view plane. Okay, then it is called as an orthographic projection. The projection, that is the parallel projection, is formed by extending parallel lines. Okay, these are the parallel lines from each vertex on the object until they intersect the plane on the screen. So this is our screen. Whereas we can perspective projection, we are seeing the center of the projection. Here we are going to give it in a perpendicular order. This projection plane, that is we are having the parallel lines. Whereas in perspective projection, we are not having the parallel lines. So these are main differences between parallel and perspective projections. That's all today. We are going to end our today's class. Before we are going to end our today's class, so we know that we are seeing the, what are the topics we are seeing? 3D transformations and the 3D transformation types, and viewing transformations. In that viewing transformation, we are seeing the different types of projections and the projection concepts.